Hi, whoever is listening to that. I wanted to how to explain something in a way, epiphany, searching for truth and searching for stuff, how things work. it's it would be a really long story after all, but let's start somewhere. That's SciTech Daily webpage, uh, May 10th, 2021. So a few days ago, basically. No, it's not. It's old, actually. It's more than a year old, or a year old. But anyway, textbooks and geoscientists may be wrong about how the Alps were formed. ETH Zurich Geology Geophysics Popular Tectonic Plates. ETH Zurich. I grew up in Switzerland, have lived there 30 years. I went to school there. We had many times we were talking about the Alps in school. We got tested. We had to give them the correct answers. And I have been there many times in the Alps, in the summer, in the winter. So that's interesting from my point of view, that whole thing. So, ETH researchers, that's the university in Zurich. Eidgenössische Technische Hochschule. ETH researchers have used a computer model to test a new hypothesis about the formation of the Alps by simulating seismic activity in Switzerland. This would help improve current earthquake risk models. For a long time, geoscientists have assumed that the Alps were formed when the Adriatic plate from the south collided with the Eurasian plate in the north. According to the textbooks, the Adriatic plate behaved like a bulldozer thrusting rock material up in front of into piles that formed the mountains. Supposedly, their weight subsequently pushed the underlying continental plate downwards, resulting in the formation of a sedimentary basin in the north adjacent to the mountains, the Swiss Molas Plateau. Over time, while the mountains grew higher, the basin floor sank deeper and deeper with the rest of the plate. A few years ago, however, new geophysical and geological data led ETH geophysic Eddie Kissling and Fritz Schlunecker, a sediment specialist from the University of Bern, the Swiss capital, to express doubts about this theory. In light of the new information, the researchers postulated an alternative mechanism for the formation of the Alps. Attitude of the Alps has barely changed. Kissling and Schlunecker pointed out that the topography of and altitude of the Alps have barely changed over the past 30 million years. And yet, the trench at the side of the Swiss plateau has continued to sink, and the basin extended further north. This leads the research to believe that the formation of the Central Alps and the sinking of the trench are not connected as previously assumed. They argue if the Alps and the trench indeed had formed from the impact of two plates pressing together, there would be a clear indication that the Alps were steadily growing. That's because, based on the early understanding of how the Alps formed, the collision of the plates, the formation of the trench, and the height of the mountain range are all linked. Furthermore, seismicity observed during the past 40 years within the Alps and their northern foreland, where I lived, clearly documents extension across the mountain ranges rather than the compression expected from the bulldozing Adria model. The behavior of the Eurasian plate provides a possibly new explanation. Since about 60 million years ago, or milliars, I don't know what MA means, the former oceanic part of the Eurasian plate sinks beneath a continental Adriatic microplate in the south. By about 30 MA ago, the process of subduction is so far advanced that all oceanic lithosphere has been consumed, and the continental part of the Eurasian plate enters the subduction zone. This denotes the beginning of the so-called continent-continent collision with the Adriatic microplate, and the European upper lighter crust separates from the heavier underlying lithospheric mantle. Because it weighs less, the Earth's crust surges upwards, literally creating the Alps for the first time around 30 MA ago. While this is happening, the lithosphere mantle sinks further into the Earth's mantle, thus pulling the adjacent part of the plates downwards. This theory is plausible because the Alps are mainly made up of gneiss and granite, and they sedimentary recover rocks like limestone. These crustal rocks are significantly lighter than the Earth's mantle, into which the lower layer of the plate, the lithospheric mantle, plunges after the detachment of the two layers that form the continental plate. In turn, this is creating strong upward forces that lifts the Alps out of the ground, Kissing explains. It was these upward forces that caused the Alps to form, not the bulldozer effect, a result of two continental plates colliding, he says. New model confirms lift hypothesis. Okay. Yeah, I will go to the point a little bit later. I will probably show you some really mind-blowing stuff, because it blew my mind too. But let's continue. Let's read it to the end, this first. To investigate the lift hypothesis, Luca Dalziglio, former doctoral student in ATH geophysics, Professor Taras Grea's group, has now teamed up with Kissling and the other ATH researchers to develop a new model. Dalziglio used ETH's Euler mainframe to simulate the subduction zone under the Alps, the plate tectonic process which took place over millions of years, and the associated earthquakes. The big challenge with this model was bridging the time scales. The big challenge with this model was bridging the time scales. Remember that sentence. Now let's continue. There's still a little bit to read. It takes into account lightning-fast shifts that manifest themselves in the form of earthquakes, as well as the formation of the crust and the lithospheric mantle over thousands of years, says Dalziglio, lead author of the study recently published in the Journal of Geophysical Review Letters. Okay, so this is how they explain. This is what I was watching for years. I read many things about all this kind of mantle dive, another mantle, and blah blah blah. Okay, I don't say it's completely wrong. This happens, probably, every now and then. Detaching and uplifting, not bulldozing. How long? Probably could watch it. 1 minute. I haven't watched it yet. This is how the Alps get formed. 10 million, 11, 12. It stops because it broke off. There's nothing anymore to push or pull. Like here on the downside. Let's go back a bit. No, a little bit more. Close. This part, watch. It detaches, flop, goes away. So it just hangs there and nothing is attached anymore. Really? Like, all this brighter stuff would be air. Like, it's just hanging there. There's nothing happening anymore. So the Alps there just stay as they are. This is probably what he tries to say. I don't know. I'm not a scientist. So, I don't know if there's any point in reading that. You can read it. I will leave the link below. Read it in with all the time you have. So, Almost. I want to show you something. Wait a second. Yeah, I just realized one thing. I said, wait a second, and I put the pause button down on the video, so you didn't have to wait. I was just doing stuff meanwhile. So this is about the perception of time. But that's another theme. Let's go to the Alps north. So here we are. These are the Alps watched from high above sky. Let's put those names away if it's possible. Map style. Clean. Thank you. So, I just would like that you watch at those. They are repetitive fractal patterns. In a way, they all look the same. Don't they? You know? They're all the same. Slight variations, some are bigger, some are smaller, but basically they look all the same. And if you go closer, the same pattern is repeating. And they still look the same. And then we have those here on the top of the mountains. This kind of I'm talking about those. I don't know how they're called, lakes, whatever. Probably many years ago there was snow there on top of those mountains. You can see this layering. And then we have those. We have a nice S. Remember this S. Now we zoom out. How can we get to this 2D, 3D? Thanks. Remember this S? What we just had before? Let's switch it around that we know to which direction we go. We will go to close to Adria, the Adriatic Sea. And we have an S. It's a big one. It's a big S. It's much bigger than the one we've found before. So, these are the Alps watched from above. Try to remember how they look, basically. Repeating fractal pattern all over the place. Now let's check some other mountains. So we have some mountains anywhere. Here's some mountains. Black and Red Sea or something. I don't know exactly where we are. Kazakhstan, Russian border. If I would show you this and tell you these are the Swiss Alps, you would believe it. Because they look the same. Don't they? I'm not really sure what's that, like mountain range. It's not Aral. Well, we are really close to Ararat. You know, where Noah's Ark touched ground. Somewhere is the Mount Ararat, I'm not sure. It has to be here somewhere. If I would tell you these are the Swiss Alps, you probably would believe that too. So, there are the Swiss Alps. Let's go to Street View. I want to show you something. Everything. Street View. Yeah, we are in Rue de Bellevue-Martigny-Ballet. That's in the French-speaking part of Switzerland. There are 4 languages in this small country. So, it's probably not the best. I haven't been prepared for this video. I'm basically never prepared. So these are the mountains, watched from the valley. They are quite high and they're quite steep. And that's the left side of the valley. And that's the right side of the valley. That's the valley. So, they are not small. They're Swiss Alps. Everybody knows them. They're huge. Not that big as some other mountains in the world, but they're big. They're big enough for Switzerland, I guess. So anyway, now I really would like to introduce you to some dude, man, someone who really blew my mind. So we are at the Thunderbolt Project YouTube channel. The following speaker is Andy Hall. After the introduction, let's just listen a few moments to what he has to say.
Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. In the recent Space News episode, Electric Universe Geology, A New Beginning, Thunderbolts contributor Andrew Hall began laying the foundations for revolutionary concepts in Earth geology. Hall introduced his hypothesis based on the principles of plasma physics and electrical engineering for the formation of mountains and other landforms and features. In part 2 of his presentation, Hall continues his discussion of evidence that massive electrical discharges in Earth's atmosphere have profoundly shaped our planet's surface.
In the first part of A New Beginning, we looked at triangular buttresses that form on mountains and within the rims of craters. We looked at evidence they are layered in place and molded in form because they were created by supersonic winds and sonic shock waves.
So, I really hope that you give him an ear and even more an eye, because it's all about recognizing patterns, everything. So, all my life I have been interested in all kinds of things, geology, like all these kind of things, weather, space weather, and you know, how the world works, because it's just something that I don't know. I was pondering about many things in my life, and I was watching clouds all my life. And this is the original picture. I was wearing polarized sunglasses. I saw a little bit more probably that's here in the picture. So I took the picture, and as I always do, I just put a little bit more contrast in it and dim it a bit down and these kind of things. I never alter them. I have no Photoshop or whatsoever. Even if I would have, I don't know how to use it. And I don't change the colors ever. And I was just intrigued by that. I noticed that there's this kind of things which has these kind of things around. Yeah, I know it looks funny. And those things beside it, and there's those strings, and there's just like, lines, patterns. And this looked interesting. You know, I was watching Andy Hall videos, not all of them yet, but stuff. And after all, I was reading about like, weather, clouds, and all these kind of things. All of a sudden, I understood that's all electric. It's the electric charge of things which make everything in a way move, interact with each other. This is where Einstein failed with his formula because he didn't define the letter M in this E equals mc square. No one knew, he didn't probably knew what's the mass. What gives things mass? It's electricity. The electric circuit in everything. The reason why, even in the smallest parts where you go, there's something spinning around something and there is space in between. So, nothing ever really touches anything because there's always the space in between. But in the same way, everything is always connected to each other. Like a human, as long as he is alive, he has to maintain 37-degree body temperature in order that he can function, that the blood is fluid enough and the oxygen gets brought to brain and toes and fingertips and hair and whatever stuff, just in order that it works. So it produces energy, it produces heat. If there is heat, energy, and all this kind of like energy, I mean, it's electric. Your heart gets an electroshock every time when it beats. That's why the muscle moves. Every muscle moves just by an electric shock. Every thought you ever had is just an electromagnetic impulse interpreted by your brain. And this is not things I figured out or, that's a quote from the Matrix movie. And I was reading books. I tried to get to the point, like I was reading even that, about the half of it. It's the Elegant Universe from Greene, Superstring, and Hidden Dimensions, and the Search for the World Formula. I read it about half, I would say. And the basic point about that, you have to imagine something and many, many other things and then mix them up and then be not surprised because you never know what's going to happen, but that's part of the plan because you just have to imagine and I thought that's really, it doesn't make sense. How can you explain like reality or simple stuff which is repeating itself all the time? There's clouds in the sky all the time. They look different, but they're just repeating themselves. You get the same clouds over and over again. But in between there are many other clouds. Probably two, I don't know. But the same pattern repeats itself. So how can it be that you have to imagine stuff? Can't be, because it's visible. Look up to the sky, you see it. It's there. It never make sense to me. I try to somehow understand the Einstein thing. He had to imagine some cosmic constant in order that his theory works. And I thought, what? Really? Somehow that's fishy. It doesn't, like, I'm not a physicist. I have no idea about those formulas or whatever. And it just didn't make sense until not too long ago. That's a commercial, I know. Electric Universe, that's the thing. Now it crashed, the whole YouTube crashed. Or what?
Onyx are evident all over the place on this mountain. You can see here how the buttresses build ridges as they layer outward. The waveform breaks down into harmonics, and these continue building smaller ridges. Some narrow and cancel, some widen. They jostle each other, competing for space and the energy of the inflow winds. But the inflow winds continue to build the buttresses facing outward, perpendicular to the wind flow. It has an almost organic nature, like cellular automata replicating. In fact, I think it is how these can be simulated, using a mathematical algorithm of cellular automata. The energy dissipates the shock envelope, but continues building ridges for a long distance at a low...
You know, let's go back to the Swiss Alps. Put all the stuff away that we can just see the mountains. You have to understand, he was talking before about those triangle patterns, not about the Alps, which is a different thing. Same principle, but you know, you have to. I will put a link below to that video we just shared, and he's talking about electricity. And if we go a little bit more back to about a week ago, I went to the same place where I was fishing many times and hanging around because it's a nice place, nice rocks, and every time since the first time I have been there, I was wondering that what kind of volcano does this kind of things, because they don't look like. And I went there and I discovered many interesting things. That's just yeah, one could think that's just lava came out from the ground, you know. But if you watch at those things closer, I cleaned them. There was leaves in those stuff. I have been on, like in Fuerteventura, Canary Islands, there's this volcanic activity, there's volcanic rocks and stuff. And I had in my hand like volcanic rocks and these kind of things. They are in no way any near close to this kind of stuff here. If you watch closely, you can see those black, dark areas. You have to understand, that's not on the surface of the rock. Basically, that's like in the rock, like it's rock. This didn't happen through sunshine or, you know, dirty water or whatsoever. That's like, this is really different from that. That's metal, that's rock. And here's the same thing. This is kind of metal, and that's just rock. Yeah, I know I'm more a heavy, or like, you know, heavy metal dude. Really metal rocks, you know. And if you watch at that stone, that's shiny. You, like, when I have been there, those times I have been there, I thought that's just doesn't make sense. Like what I have been reading about, like volcanic activity and these kind of things, just didn't. How? What's that? You know, that's a small crater. And if I watch it that closely, that's 1, 2, 3, 4, 5, 6, 7, 8 layers. Like if you would watch it from the side, it would go like that upwards. That's the top. And this is where it goes down. It's that one, steep. I don't know if you understand what I mean. If anybody of you ever welded, you probably understand what I mean. So, if you go back to the Swiss Alps, quickly just watch at them. Or actually, I could show you this other picture. Yeah, I made this earlier. Watch for yourself. Any similarities in that? I would say they look quite like the same. And here, I know this one is not the best, but there are similarities in those two. This one is from the rocks I showed you before. And that's a crater from the moon. They are quite similar. That's the rocks I took a picture, and that's Finland from Google Earth, the lower one. That's just black and white because, you know, here we have forests and lakes, and that's just the rock which is dry. So, I would say that there is no doubt that those guys from ETH and Zurich never heard about the electric universe. Or probably they heard, but they can't admit being wrong. And the most sad thing about that is that there's a huge amount of money given to those people for tapping in the dark, denying any critical evidence for whatsoever, because otherwise there would be no work to do anymore. Textbooks and geoscientists may be wrong about how the Alps were formed. Yeah. The funny thing is, it's in history written down, all this stuff. It may be quite likely so that instead that the Alps were formed in a long process which took millions of years, tens of millions of years, hundreds, I don't know. Instead of that, they have been probably formed in, I don't know, 10 minutes. One huge lightning strike, and ta-da! Alps, check it out, ready. Let's wait a bit until the dust settles. But they are done, they are there. They came into being in an instant. Which implies that whatever history book you ever read, or these kind of things, like read about volcanic activity and tectonic plate moving, like really slowing, lifting them up, and oh no, it quite likely might be wrong. Of course, there is volcanic activity, there's mountains growing by volcanic eruption, like in Iceland at the moment, and all this kind. Yeah. I don't say that they are not like right with this volcanic activity in some places, but mostly there are no volcanoes near anywhere. There are no volcanoes in Switzerland. There are no volcanoes in Finland. And there are many other places where there's big mountains and whatever stuff, but there's no volcanoes around anywhere close. So, it was just a lightning strike, plasma discharge, which happened some time ago, but didn't take long. Think about that. Thanks.